Evening. How are we all doing? Yeah, we actually had an early shower tonight, so I should have been here exactly on time, but I had to sort my desk out. I pulled it away from the wall so I had more leg room, and of course that then moved the camera, and then everything needed sorting. It's a me. So we will crack on tonight with doing our key giveaway for this month. We're a little bit late, we should have done it earlier, but we got there in the end. So if Claire could signal her readiness, and then we will go ahead and get cracking with it. Oh yeah, I forgot about the crash last time. Yeah, I'm not sure exactly what it was, but I think the test map had lost its reference to game state. So whenever the game tried to load, or whether the engine tried to load, it was just crashing out with a null reference. And rather than recovering from it gracefully, it was just crashing to the desktop. So what I did is I went into the ini files and just removed the default map. So rather than using the last used map like I've got it set to, it loaded the UE5 default map, and that worked. So then after I went in and loaded and saved game state, everything worked again. So I don't know what it was. It definitely wasn't a corrupt blueprint, because I replaced game state from a backup, and the bug was still happening, it was still crashing. So I think it was an issue with the actual local map file itself. But yeah, it's all fixed now, so we're all good. And yes, it is competition time. So let me go and find the right thing. There we go. Let's get rid of my face. Oh, hang on, Claire's broke something. That looks about right. Okay, so once again, thank you to T-Shane for sponsoring a couple of captain ranks, and we'll do those first. Yeah, stop messing with my spreadsheet. Okay, so the first captain key goes to 8146. And that is Space Banana. Congratulations, you are now a captain. Just waiting for Claire to be ready again. She has to do admin stuff in the background. Okay, and our other captain key goes to 4609. And that is Anteater. Congratulations. You are now a captain. Oh, that's good. I like it when people that have been waiting ages finally win. Well-deserved wins. Okay, so the next three are just keys. And the first key goes to 3425. And that is NT Witch, congratulations. Have a key. Okay, and the next key goes to 3133. Goat Warrior, great name. Congratulations, you have a key. I didn't spot that, but yeah, they are. I'm sure it's not a reference to me. Okay, the last key, 4372. And that goes to Hamavet. Hamavet. Not sure I'm pronouncing that right, but congrats, have a key. Okay, there we go. Well done to everyone. Congratulations, and thanks again to T-Shane. And Claire will be pinging you on Discord, so keep an eye open for that. Right, let's get rid of them. Go over to that. Right, and do that. So at the end of each night, when I've finished working, I work on planet stuff. That's kind of my my happy place, where I just beaver away on things that are kind of off patch, just to have a bit of downtime. This is how far I've got with the new planet tech. I'm going to just decouple that from there a minute, so that I can move it out of the way. That will be volumetric clouds at some point. It's not great at the moment. I'm still having some issues with it, but hopefully we will have global volumetric cloud coverage once I've got all that tweaked. But I'm really happy with how the planet shader is coming out. I've refined the way that the noise is being drawn, and rather than combining the ridges and the gullies masks, I'm adding them on afterwards. So I'm using like a grayscale map for ridges and gullies, and I'm applying those after we've done the first noise generation. And what that does is it adds extra detail on top of the erosion, which just gives you a bit more visual detail to it, which is nice. And just the general layout of it is starting to look a lot nicer now. As people quite rightly point out, it does look a bit like a cauliflower or a sprout or cabbage, but yeah, we need to work on scaling this down now, and do the continents, do the continental plates, and really get it looking more like a planet than a cabbage. But the important thing is that the erosion is working really nicely, and we're able to properly colour the terrain based on altitude. So it's going ahead and it's drawing snow as a separate layer, for example. I need to blend some of this in a little bit better. So we've actually got five different layers that we're blending. So we've got the water level, which is tweakable as a parameter. It looks like it's 3D, but it's not. It's a flat surface. I've just shaded it based on water depth. Then we have a little bit of a coastliney area, and then we have lowlands and highlands, which are just just a gradient going up, and then that goes into mountains and then finally snow. But once they're blended together a little bit more smoothly, we shouldn't have quite as much of a solid cut-off. And again, obviously this all needs scaling down. And I think I'll work on making it so that the erosion is stronger the higher the altitude is. So as you go down in altitude towards sea level, it will start smoothing off the erosion, which will result in smoother plains, and the lowlands won't be quite so eroded looking. But yeah, it's coming along, and I'm loving the really kind of legit looking mountain erosion that we're getting from this. So I'm quite excited about making this a proper planet as we go on. But anyway, that's a little side project. What I got finished after I fixed the build after the stream on Wednesday is we've got command orders being raised now upon completion of our find text signatures sensor order, and that can now be acknowledged by the captain or the commander. So if we just go find text signatures, so literally just a couple of clicks and they'll go ahead now and search for text signatures all on their own. Obviously I've set it up so there's definitely one on this particular system, and you'll find that once they've finished doing their survey, it will flag that a text signature has been found, like so. So their own order has disappeared because they found text signature, and they've responded by raising a command order, which is basically census report text signature identified in system. Obviously we need to present this in a more obvious and nicer looking way. For testing purposes this will do, but we definitely need to make sure this is presented better. We need things flashing and beeping and actually raising an alert to let you know that that attention is needed. And then you don't actually need to do anything with it. You're just acknowledging, okay, acknowledged. So you now know that the sensors have found a text signature, you've acknowledged that, and the game is basically just waiting for the captain now to make a decision on what to do next. So given that we now have that, the next course of action is probably going to be fly to that system and do a medium range survey, and maybe even check out that world in person. To make this easier, we need to flag things like text signatures on the holo display, because I feel that the missing piece here is that the sensors have done their job. They have found the text signature that we asked them to find. As the captain, I've acknowledged the fact that they've said, right, I found something. And then you're kind of left with a sense of, okay, now what? So I think the next logical course of action is you would go, okay, so if that's the one that has the text signature, we can set that as our command target, and then either get the helm to fly over there, or maybe raise just a generic ship-wide order that says something along the lines of scan this object, scan this planet, so that you're telling the crew, now that we've identified there's a text signature there, fly to that planet specifically and perform more surveys, which seems like the most direct way of going and analysing what that text signature actually is. But yeah, so that's kind of the next step in the process that we need to look at. Yeah, tree lines are... oh, hang on, are you talking about the planet? Or, yeah, I see what you mean. Do you mean tree lines on here? Because if so, then yes, we can do that based on altitude. It'll be difficult to get slope angle. I mean, it's not impossible, because the erosion uses slope angle to some extent to do the erosion calculation. I'd have to have a look and see exactly how it's doing it, but yeah, slope angle is actually a factor in this. So we can combine altitude with slope angle and use that to determine like forestation and that sort of thing. And obviously at some point I also need to do a global temperature mask over it as well, so we can define, you know, where the equator is, where the polar regions are, and drive vegetation from that as well. But yeah, it's the more masks that we can generate from the data, the more we can draw in a kind of semi-procedural way. So yes, we're generating it all procedurally, like this entire thing's all procedural. None of that's been handcrafted. But it's rules-based procedural generation. So things like drawing forests aren't going to be random. They'll be based on the data that's being generated. So it's kind of like semi-procedural in that regard. Delta, yeah. So the radial menu, obviously I've built it on a 1080p screen. In fact, so where's the cutoff there? So if we look at where the dead zone is right now, it's kind of like it's away from that edge. If I full screen it and we bring it back up, see that the dead zone is now aligned to the edge of the circle. So when I set up the dead zone originally, I set it up to do the transition right there as you leave the inner circle. But it's screen size dependent, so it's not obeying screen percentage. It's literally doing it by pixels. So if you make the screen smaller, and obviously the dead zone is now moved. So if you're on a 4K display or like an ultra wide display, it means that the dead zone is in a different place. So yeah, it could be extended all the way out over here past the ring in some instances. So I need to just go through and work out how that's being calculated and adjust it accordingly. So so that the dead zone is screen resolution independent, and that will stop that from happening. Danger Mouse, the NPC raises that alert with the captain directly, and I think for a player we're just going to have to do it from the captain's chair. So if you look at the captain's chair and press your interaction button, then whether they're in the chair or not, there needs to be an option on there to just raise or just acknowledge task completion or something like that. Or probably even better, have it on here. So rather than have the current orders just disappear, if it's something that has a defined objective that the captain needs to action, then we'll have the button on here instead. So when you click it, that gets rid of the orders from the sensors and automatically raises something over there for the captain to look at. And if the captain is not on the bridge, then the ship's computer needs to make some kind of an announcement to call them to the bridge, to just acknowledge the fact that they are needed. But again, we're doing it iteratively, so we'll keep refining that as we go until we find the sweet spot. Yeah, so the ability to save locations and recall them for later perusal is definitely on the to-do list. The sensors console will eventually be tabbed. So right now, this is sort of active sensors. So this is showing you live data. I want to add a second tab for astrometry, or just astrometrics, or just astrometric database, something like that, whereby it'll have a database of everything that you've scanned to date. So you'll be able to go through and pull up the data for basically every star system you've scanned, and all the information relating to that system. So you'll be able to go back through basically everything that you've scanned to any degree. And on the helm, well, it's kind of already half done, in that there will be a data entry keyboard eventually, and a list of things that you've saved on the helm. So things like Earth will be like pre-populated on the Sol, and just generally the Sol system. So you'll have the ability to, wherever you are, so say you're parked in orbit around a different planet, you'll be able to save this exact spot in space, like literally down to the kilometer, in the database, and you'll be able to name it as a location. So if you find something cool, then you can just save that into the navigation database. So there'll be two databases. One is nav targets that have been saved, and the other one will be things that you've scanned. And both of those will be recallable on the conference room screen in the conference room. So you can bring it up on the big screen and sort of have a conference over it. Idea 8225, yes. So the next thing we're building, literally right now on stream, is going to be finding Earthlike worlds, or at least Earthlike candidates. So this is the code for finding text signatures, which I've literally just copy-pasted onto Earthlike candidates. And the idea is the Centre's NPC will do long-range scans of basically pre-selected star classes. So they'll focus on the classes that are most likely to have an Earth-like world. And if they find a terrestrial planet that happens to be in the habitable zone, then that's a valid target for exploration. So they'll alert the captain with that specific target in mind, and then the captain can say, okay, let's go take a closer look. So what you're asking for there, basically is that, because we can't derive the presence of life from the long range sensors, or even from the medium range. You need to do a short range scan for that. So if a planet has life on its surface, you need to scan it from orbit. So the only way we can guess that there might be life there is if the planet itself is in somewhere that has liquid water, for example. Obviously there will be other types of planet with different types of life, but those are the obvious ones. Yep, there will be ship-to-ship combat. We have a tactical console here for that very purpose, and guns that you can't see because I'm on my test map. Yes, there will be combat within the game. It's not our primary focus. Our primary focus is exploration and discovery. But yes, if you get to a star system and the species there are particularly hostile, then yes, they are going to be shooting at you, and you will be able to shoot back. Not everyone in the galaxy will be friendly. In fact, some races will be downright hostile. But I guess that's not the point of the game. So the point of the game is to get out there, make discoveries, perform science, meet alien cultures, try and make successful first contact, and all the good stuff. If you find yourself in a firefight, then we're viewing that as a failure of diplomacy. So that's when things have gone wrong rather than gone right. Although you're of course perfectly free to go in guns blazing wherever you want to, because we're not limiting player agency in that regard. So, if you want to just go around shooting everything, you can, but that's not the point of the game. Okay, so the first thing we need to do here is work out what our actual criteria is. So we have done our long-range survey, and we've got our sector location. Now, what we don't have is any details for planets or anything within that system. So we need to get that from the star system gen system. So we need to make sure that we request that. So if we get our game state, I'll make a more of a reusable macro for this, I think. Get system gen, was it location? That's the one. Right now this is a blueprint component sitting on game state, and it really needs to not be. I set this up years ago before I kind of knew better, so at some point I need to get this off of game state and have it as a standalone system in the world, but for now it just lives on game state. And then we want to get sector location details. So what we do is we give it our sector location, and that's basically the sector we currently have the sector location we have selected, and a sector location is a 1 light year cube within a sector, and this will go ahead and generate the full star system. So the galaxy gen just generates that basically a really tiny amount of data for each star system, the absolute barest minimum, because there's so much of it in an array. And then whenever we want the actual planets and all the rest of it, we have to generate that separately. So we can get rid of that. Okay, so for the currently selected sector location, we're going to generate all the planets and things, and obviously we get much more stuff then, including an array with all of the satellite objects. Now for each of these, what we need to do is we need to take the distance limit for the different zones around the star. So so we've got the zone limit for hot, which is the habitable zone start, and then the zone limit for the habitable zone, which is the outer edge of the habitable zone. And we need to see whether or not, if we grab the details for the planet, and specifically their orbital characteristics. It's a lot of stuff in the structs. So this is the orbital characteristics of the planet. So we want to take their average distance and work out whether their average distance from the star falls within this range. So we want to do in range. So the minimum is the outer edge of the hot zone, and the maximum is the outer edge of the habitable zone. So basically we're determining if this planet spends most of its time in the habitable zone. And if that is true, then we can determine that it has a chance of being an Earth-like world. It's not necessarily guaranteed to be an Earth-like world, but it has a chance to be. Oh, actually, we also need to know whether it is. Whether it's a terrestrial planet. So did I store base type? No, I didn't. This might actually give us too much information. So we might have to narrow this down a bit. Yeah, so this is the actual final class of the object, not the base class. So really you've got terrestrial planet or gas giant. Those are the two base classes. But we want to make sure that that we include all the potential ones, so that we're not specifically singling out terrestrial atmospheric terrestrial planets or Earthlikes, because we want to make sure that that there's some ambiguity there with the scan, because we shouldn't know that it's an Earth-like world until we've actually been there and done our scan in person. I will add base type to the struct so that we don't need to do this. We can just see whether it's a terrestrial world or not. I mean, technically, I suppose a dwarf planet could maybe hold on to an atmosphere. Like, maybe. We'll include it just in case. And also, kind of as an outlier, a water world in this instance isn't like an Earth-like world that doesn't have any land. It's a true water world where the atmosphere is very, very big and very, very thick, and it is predominantly made of fluid. But the definition between ocean and air is much less well defined than it would be on an Earth-like world with no land, if that makes sense. I guess true water worlds are it's where a terrestrial planet kind of starts looking more like a gas giant. So it's like a super Earth that has a very thick atmosphere, and it's kind of that transition point where it becomes a gas giant at some point. Okay, so we've got our zone extents. We're going through each object in the system. So we want to know, is it any of those, and is it within the habitable zone? So if all of that comes back true, then that should be it. That should be our criteria for this search met. I think fortunately there actually is naturally an Earth-like world in Alpha Centauri, so we can actually test this. Okay, so close that off. So census report, Earth-like candidate identified in system. What I'll do is maybe turn this into a target so that we have that set as part of the command order that gets raised, because if we can click a button and make the thing they're talking about the command target, then that can kind of streamline the process a little bit. So all they need to do is press the button on the command console and it will actually highlight the system, or rather the object within the system that has been identified as having the search criteria. Okay, so the rest of the logic should be exactly the same as finding a text signature, because we are making sure we're on the long range mode, seeing if there's any unexplored targets, focus on it, do a long range survey. Yeah, so all of that should be the same. So hopefully copy pasting this is not broken anything, but we'll give it a whirl and see. I guess we want to end the search with having that object targeted by the sensors. So let's just give that a quick test. So sensors orders, find Earth-like candidates.
Initiating long-range survey. Long-range survey complete.
Yeah, so we have a planet here, and it's definitely skirting the habitable zone, but it's within it enough that its average distance falls within the habitable zone. So that is being flagged as a match. Didn't raise the command order though. Okay, let's see why not. Yeah, so that shouldn't stop scanning. That's doing no different. Just realised a logic flaw here in that although I suppose we can output from there. Just thinking that obviously it's continuing to do the rest of the check, but if we break the loop from there, although I suppose we need to do the output first and then we can go ahead and break the loop, just making sure that it doesn't carry on doing this, because otherwise it will set that. Although actually no, we want to do all of this on here, so let's do this down here by way of a branch instead. And before we do the loop, we will grab our criteria match boolean that we keep using. So that will only be true if we find some matching criteria. And then we can output true. Yeah, that's better logic. Yeah, I do desperately need to put another video out. We were supposed to do one in January and do a January update, but we'll just save it for when we do the actual build and put this live to the public. We'll do a full update then.
Initiating long-range survey.
Okay, there we go. So,
Long-range survey.
okay, so that last system, interestingly, didn't meet the criteria. So that planet that was skirting in and out of the habitable zone was not in it long enough for it to be happy with it.
Long-range survey complete. Initiating long-range survey.
Okay, so the sensors will now go through system after system, looking for that Earthlike candidate in the habitable zone.
Long-range survey complete. Initiating long-range survey.
See, this one looks like it's got one in it.
Long-range survey complete. Initiating long-range survey.
Right, okay, I'm pretty sure it's skipping some there, so let's just make sure that we're actually getting anything at all in that array, because it might be the case that our galaxy location generator is not actually outputting anything. This really needs tidying up. Look at the state of this. Okay, so we're definitely... Oh, I think I can see what's happening here. We're broadcasting it out, but we're not necessarily returning it, because we're skip broadcast is false. So we're setting that as our sensor sector location details, so the thing we have clicked on the sensors, which should be the case anyway, to be fair, but we're not returning it from the blueprint interface, which means on here, when we do get sector location details, this wasn't actually being populated by anything. So let's try it now, because that should actually have some data now. So hopefully this first system should flag. If it doesn't, I'll get it to do a bit of debug spam.
Long range survey complete. Initiating long range survey.
Right, so that definitely has a planet right in the middle of the habitable zone. So this one should flag. If it doesn't, then something's broken.
Long range survey complete.
Yeah, so it's not getting what we need it to get. Okay, so my assumption is this is failing, so let's just have a look a minute. Right, so what do we need? Let's give ourselves a bit of a data output so we can see what's going wrong. So sector location is vector 1, sector location details is vector 2, then we've got zone. Actually, before we do zone limit, let's do, yeah, actually no, we'll do zone limit next. Zone limit hot. Then zone limit habitable. Okay, what's those? So we need to grab the vector from this one. And the same with this one. And then we want that and that. And I guess for now we'll just see how many planets there are. Because if that's coming back with 0, then we're definitely not generating anything. Right, let's see.
Initiating long-range survey.
It won't create the debug until it's done the scan, because that's when it then checks its criteria.
Long-range survey complete. Initiating long-range survey.
Okay, so yeah, so we're definitely getting system details. So 99 million kilometers to 192 million kilometers. That's our habitable zone, and it's showing 15 planets. Okay, so and the vectors matched, so we know that we're getting the right sector location details. So I guess the next thing to check, so we know that that is all good. So it must be something over on this side that's failing. Okay, so we won't bother with the vectors. We will keep our zone 1 and zone 2 numbers, and then we'll do the average distance of the planet. So that should fall within this range, and then we just need our type. Which will be that. Okay, so we should get that pop up for each of the 15 planets. Yeah, it's going to be for all of them, so let's just make that last a while. Oh, thank you, Danger Mouse. It's funny you should mention that, actually, because I did weigh myself today. I'm 101.4 kilograms, and at my best weight during my diet, I was 99.3. Just made it under the 100. So, yeah, I've let it slip by a couple of kilograms over the past month. So I definitely need to do a bit more work. I'm trying to get down to about 85 kg, something like that.
Initiating long-range survey. Long-range survey complete. Initiating long-range survey.
Let's just kill that a minute. Yeah, that's no good to us. So hang on, let's narrow that down. So we don't want it to spam anything if it's not one of them. So let's just do that a minute.
Initiating long-range survey.
Yeah, I'd quite happily work at double speed. The more I can get done, the better.
Long-range survey complete.
Okay, so the Earth analog.
Initiating long-range survey.
So the average distance. Oh, that's way longer. Oh, you know what? I think we're dealing with that whole centimeters to kilometers conversion, because the limit of the habitable zone is 192 million kilometers, but we've got 18 billion centimeters. Oh wait, is that even
Long-range survey complete.
more than that? That was 18 trillion centimeters. Okay.
Initiating long-range survey.
So the same thing here. We've got limit of 114 million kilometers for the habitable zone, and then 8 trillion centimeters for the average distance. So that should be easy enough to fix. We need to change that. Oh, need to do that the other way around. Hang on, let's just make another macro for that. I think it was 00001. No, more than that. This is a job for the length converter. Right, so 1 centimeter is that many kilometers. Oh, hang on, four zeros. I think I did get it right, actually. 4 zeros. Yeah, I did get it right. Right, so centimeter to kilometer. Okay, so that should do it, assuming that that was indeed the problem. Hey, Sirius, good to see you. The reason we're using centimeters is because that is the Unreal Engine unit of measurements. So one Unreal unit is basically 1 centimeter. It is a metric system. So the
Initiating long-range survey.
the world in which the ship is flying around in is 1-to-1 scale with the real world. So everything has to be in centimeters. So the Earth being 1 AU away, that's literally 1 AU in centimeters in the game engine. That worked. Okay, so got a command order. Sensors report Earthlike candidate in identified in system. Okay, so that's good then. So we've got that working. So it will basically stop searching if any planet, any terrestrial planet, is within the habitable zone of a star. Now, at some point, we will flag that on here so you can see it visually. Yeah, so that's good. And I think what we'll do is we'll end this with that having been targeted. And we need to make sure that the sensors automatically update to have that like in visual range. Yeah, I guess we're measuring it to the star. So whatever target we click on has to be like within visibility of the star when we do that. So it doesn't sort of end up like that with nothing selected. Oh, that's interesting. Why is that vanishing? I've done a lot of optimization on what is drawn and when, and it kind of flakes out a little bit if it's in a highly eccentric orbit. Like if we zoom in on that terrestrial planet there, as we go beyond the limit of the holo display, you can see it stopped drawing it because it's now off the display. And similarly, on the inside edge here, this terrestrial planet that we have targeted, if we let me just zoom in so you can see it a bit better. If I can get it in view. No, I can't. Okay. But if we zoom out, after a certain amount there, it's stopped drawing that inner planet because it's got so small on the display that all the text is overlapping. So if we just go out other way by one click, you can see that it's now back again. But any smaller than that, it stops drawing it. So if we zoom out lots from a star system, then basically none of the inner planets are being drawn anymore because they're so small. You've zoomed out so far that they're basically irrelevant. One, that saves on performance, and two, it stops all the writing overlapping. But it does mean that when you target things on the list, obviously we're moving the display around. We need to make sure that we automatically scale the display so that the distance between the object and the star is equal to the distance between the object and the outer edge of the display. So it's always keeping it basically about like that in terms of how much you can see. So when at the end of the scan, the NPC says, right, I'm done, that's the target of interest, we need to make sure that this display automatically zooms in to about there. So you can see that object at the correct scale for where it is in the system. Okay, so both this one and the text signature one, yeah, so having having confirmed our criteria match, as part of raising the alert for the captain and closing the orders, we also need to make sure we target that object. Although I suppose we could do it. We could do it here, actually, couldn't we? Because we've got the data available to us. So, do we have a reference to sensors? Yes, we do. So update sensor target. Not sure that's the one I want, actually. Probably more that one, to be fair. No, we don't want this one because it's going to do bad things. What we want to do is we want to override the target selection, which would be that one. So update sensor system target. Okay, and then similarly for text signatures, I think what we'll do with this actually is we'll make this a little bit more specific. So if we grab exactly what we're doing for this, and then we do that on here instead. Hang on, I've just remembered a gotcha that breaks things, and that is if you copy the output node, it messes things up, so need to make sure we don't do that. Okay, so we're checking different criteria this time. So we're not interested in habitable zone stuff. We're interested in our sieve data. Don't think we've got any tech stuff there. Let me just have a look a minute. We'll use this one. Oops. Okay, so a similar approach where rather than checking the system as a whole, we loop through all of the individual planets, and then we check to see whether any of those have a name associated with them. If they do, then we know that there is a civilization there. And we don't need to care about the temperature zones on that one. And then everything else is the same. Okay, so both of those sensor tasks should now end their scan with that object having been selected. And then we'll make sure they zoom in properly as well. So if we start off with the text signature one.
Initiating long-range survey.
So normally it will end with the last thing it scanned being targeted, or the star. So we just need to make sure that it ends with the object in question being targeted.
Long-range survey complete.
Yep, which it looks like it just did. So if we zoom in, yes, so we're ending our scanning process by having the thing that is the thing with the text signature is the thing that is left targeted, so that's good. So at this point we could literally say navigate to there. Actually, why are we not? Oh, I know why. Because we haven't done that. Beep. Now we can go there. Yeah, so from this point, as the captain, we can say, okay, great, go there then, rather than necessarily setting it as a command target. But now that we know which object we're talking about, we can just set it as the command target if we so desire. Okay, yeah, let's just make sure we do the range. And I'm wondering whether we actually do that literally on here. So we've got the range that we can do there. And the same range there. Oh, I pressed the bad button. I keep forgetting that this blueprint is so big that every time you try and hide the pins, it has to check references to all of them, which takes a few seconds. Okay, so if memory serves, and let's do these one at a time so we don't break it, we should be able to take our average orbital distance for the object and then just update our display range accordingly. So that's in centimeters, obviously. So we can do centimeters to kilometers because we made a macro for that. Yeah, that should be a radial distance. Let's just give that a try a minute and see whether or not it gives us the right zoom level. It took me about an hour or so, serious. It was a really simple fix in the end. I just had to remove this map as the default map when the game loads and change it to the Unreal Engine default map instead, because this particular map had got, for some reason, it got itself a corrupted reference to game state, which is why it was doing it's just, you know, it's hard crash every time you tried loading the engine. As soon as I got into engine and resaved everything, it was just fine from that point. So I don't actually know what broke or why, but it fixed itself, and that's all that matters. Okay, so if I target things here, it should be, yeah, so it's right. You can see what it's doing. It's zooming the display, so the thing that's targeted is right on the edge of the display. Oh, hang on, is that in AUs? Maybe we'll do half that distance. Oh yeah, because we're zoomed in on the ship. Hang on, I see what's happening here. So because the display is oriented to the position of the ship, we can't measure it to the center of the system, so this average distance doesn't work. So instead we need our local coordinates, and we need to know where the ship currently is. Hopefully that won't break it too much, it's just a few things. Okay, so the distance between the object location and the ship, which again is in centimeters, that should make a bit more sense, but I think what we'll do is we'll extend that maybe by 25%, so that it's not placing the object right on the edge of the map. Let's just give that a try. And also we'll need to make sure that we're not on object focused view either, because if we are, then in that instance we do need to scale it based on its distance from the star. That's where it gets complicated, because the display can use different objects as its center point, and every time you change what thing is the middle, obviously that changes how the map works. Right, so Mercury is in range there, and if we go through each object, yeah, so the map will keep zooming out accordingly. So every time you click something, it just makes sure that that object is definitely visible on the display. Yeah, that works. So I think maybe we'll make it so it's not quite all the way over there. Maybe 50% rather than 25. Yeah. Yeah, it would be lovely to have it be a smooth fade to each thing, but the issue is that we redraw the whole display every time we change things, because there are multiple factors going on for drawing everything on the holo display. You've got the size of the display versus the display range in kilometers, and of course you then have to convert that to centimeters locally for the size of the display, and obviously then you've got to draw the ship location and all the lines and everything. So what it does is every time you zoom in or out, it redoes all those calculations, which is why it goes kind of because it's kind of recalculating and it's redrawing the whole thing every time. When we move the ship, it moves it smoothly left and right, because all we're doing is we're moving the thing that we draw, we're just moving it around. I suppose what we could do is draw the whole thing big and then scale the actor rather than redrawing it different sizes. Obviously, redrawing it causes a hitch in the game, so we need to make sure that we manage that. But if we can scale the object up and down rather than redrawing it each time, then we could do smooth transitions between each zoom levels. But yeah, at the moment that's not possible because of how it's rendered. Although I agree, smooth would look better. Yeah. Having it shimmer or something could be a way of doing it. I'm sure we'll come up with something nice looking. Ultimately, scaling the actor would be the better way of doing it, because the shader that draws the planets and draws the lines and everything, that shader has an origin point and a maximum view distance. So if like the line from an orbit goes outside of the display, the shader cuts that off at a shader level because it's beyond the draw distance that we set. So we can scale the actor arbitrarily, draw the entire star system and just make it bigger and smaller, because the shader takes care of things not being rendered where it shouldn't be. I think my only concern with that is obviously as you make the thing smaller and smaller and smaller, the planet indicators will get smaller and smaller, unless we make them an image that we put in screen space. We could maybe do that. Yeah, there are solutions to it, I'm sure. Hey Melissa, good to see you. Okay, what do we want from this? It's this focal point that is the issue here for the range. But I'll leave that for now and do that as my final polish, because the core code of it works. Let's just make sure that the sensors actually do that.
Initiating long-range survey.
Okay, so what we're looking for is when they're done, they should target the Earth-like world with the text signature, and the display should make sure that's in easy view.
Long-range survey complete.
Yep, okay. That works. Yeah, so interestingly, I think this is mode dependent as well, because in this particular mode, the thing we're clicking on, that's the focus of the sensors. So it's object focus, because the ship itself isn't in this system, so it can't focus on the ship. But because each star system has the same coordinate space, from 0 to half a light year, obviously the ship is within a star system, so that the ship's coordinates are still relevant to the measurements. If the ship was parked right on the outskirts of that cube, then it would be zooming in a really awkward way. Yeah, so I will make sure that we handle that accordingly. Again, that's kind of more of a final polish thing. Alright, so the other thing we want to do is, in the same vein, make sure that
Initiating long-range survey.
make sure that they focus on the Earth-like world when they're done.
Long-range survey complete.
Yeah, there we go. Okay, so again, they're finishing on the right planet, and they're ending up with that one targeted, which is perfect. That's exactly what we want to see. And I should have 2 orders on here, I think. Yeah, 2. So so we can acknowledge the text signature one, and we can acknowledge the Earthlight candidate one. So I guess we need to add a set command target button on both of these. I guess in addition to the acknowledged, then we can just get, yeah, okay, done. Do we have a center helm thing on this, just to and then we don't specifically, do we? So I guess that's needed. I suppose we could set that maybe under orders. Again, we don't want to bloat this menu too much. But yeah, so on the long range. Although center helm is more of a generic thing. I'll have a think about the best place to put that, because again, right now, if we were, we're the captain, we're walking around, we're talking to people on the bridge, we've asked them to look for an Earthlike candidate, they found one, it's currently targeted. So I suppose the next thing we would do is say, okay, send that to the helm, and then we'd say to the helm, right, go there. Although we can just click it and then tell them to go there, and then they will select that as their nav target and take us there. So there is a way around it. I'm just wondering whether or not giving them the send to helm command might be something we need to add. Okay, well at the very least I'll add it as a button on there. I can Renzo actually, yeah, if I figure out what I was doing for that. Different blueprints have access to slightly different bits of information at different times. This is like the root of the sensors though, so this one should have access to all of that. But basically all I need to do, and this is what the other one will be doing, is we can either switch on sensor mode or on the focal point of the long range sensors, and just do a select on that. So depending on which one of these it is, the range we give will either be calculated from this, or we'll calculate it via orbital distance instead. But we can just use a select statement on our sensor mode to achieve that. So it's easy to fix. It's not a complicated one, thankfully. We do, however, need a button on here. So if we get rid of that, duplicate that. Just do that, just quick and dirty for now. Doesn't need to look pretty, just needs to work. Yeah, I guess on the command console itself, we need another function on here. So if we just make a custom event, set command target, and I guess we need the target details. Do we have that? Sure we do. Yes, we do. Orders target. So we grab that. So set command target. and then we'll just give it that. Obviously we need to add that as our inputs. Actually, I just need to make sure that I'm setting that the right way, because I might actually have only set that up from the holo display only. And I imagine we'll need to pass that through player controller to make sure that in multiplayer it's usable by clients. Otherwise it will only work for the host. So we want our holo target, that one. Oh, okay, so we're doing it from player controller already. That's fine then. That's good. Which means on here, nope, on here, nope, on here, we just need to send that straight across to player controller. Should do us. Let's give that a quick try a minute. Ranza and Sirius, yeah, I think you're right. That's probably more of a ship-widey type order, because the way I want to separate these things out, and I was talking to Claire about this the other day, about how intuitive this is or is not, but the general idea is, if you're speaking to the sensors guy specifically, then it should be a very sensors oriented list of options that you have. Similarly, if you speak to the helmsman, you should have only helm relevant stuff available to you. If, however, you just look at nothing and press F, then the orders and the things you can do should be relevant to either you as a person or just generally the room that you're speaking to. So if you go to orders and then ship-wide orders, you're speaking to the entire bridge with this, not an individual on the bridge. So I guess navigate to sensor target, when there isn't one sent to helm, I guess is what you're saying. You're saying to the bridge in general, okay, navigate to the sensor target, which means the sensors guy says, right, okay, I need to send this to the helm, and then the helm's going to say, right, I'm waiting to receive a target, and then off they pop. They've got their orders, and then we can track that as well on the task manager to make sure that ship-wide order stays in the system until you've actually arrived, within the arrival distance specified. So yes, that does generally make more sense. Right, let's just get that done so we can test the command order.
Initiating long-range survey.
Yes, Melissa. Right now, the bell button doesn't do anything, but when I find a suitable doorbell noise, then yeah, there will be a doorbell. Right, okay, so we finished our scan. The sensors have ended with the object targeted. So if we click this, it should set a command target there. It might have done it, but not updated the display. Hang on, let's just update the display. If I tell him to navigate to command target, does he pick that one? No. Where are we going? Okay, I guess we're going to Sag A. Yeah, okay, so setting okay. Yeah, it's coming up with all the zeros, so something's not getting through there. Right, okay. Let's trace where that's going wrong. Right, so we've got our orders target that we're setting there. Oh, I know what's happening. Right, of course. So what we're not doing is when we are raising this, of course we're not actually setting the target. So we do actually need a reference to this. And I suppose we could just set it as an output. Probably better if we set this as a local variable, maybe. Actually, no, we can't because we're on the event graph. Yeah, right, we'll just use it as an output. So match objective target. If we set that as helm, let's spell it, shall we? Always helps if you spell things properly. Yeah, if we set our objective target as basically the details that we pull from here. So there's a few things we need to create a successful target. Obviously we need the coordinates. We need our object type. It's not a star system. And then we need a name and a radius. So name comes from our text field, so we'll just use the base name for that. And the radius comes from our physical characteristics. So get our body radius. Right, so now we're actually outputting an actual helm target. So on here, we need to input that as our objective target. And now we've got something that we can plumb into there. Okay, so now when we press the button, we're actually using some actual data rather than nothing at all. Right, so if I grab that, because we need to do the same thing on the Earthlike one as well. So add that as an output. And that is our objective target. And then we'll put that in there as our objective target. And we can add that to our target on the command order. Oh yeah, and actually plug that into something, that would help. Actually, while we're here, let's go ahead and let's do the old generate hash thing for the order's ID. Just wanted to see how well that works, because it's a much better way of doing it rather than a random number. Right, let's try that. No worries, Melissa, thank you. Enjoy your duty shift. Illusion, yes, there's a few things on the NPC specifically that I want to macro up, because there's a lot of repeated steps that we're using that really we need to be pulling in across multiple types of orders. So yeah, right now we've only got the two scripted things that they can do, but we want to add a whole bunch of different stuff. Like, rather than finding an Earthlike candidate, we want something like find a black hole or find this particular class of star. Yeah, so there's definite expansion, scope expansion that we want to add to this. But of course, a lot of the logic is duplicated logic, because when it comes to selecting the right sensor mode, performing a scan, those are repeated actions that we shouldn't have to code from scratch every time.
Initiating long-range survey.
To begin with, it's a human-only crew, and our general plan for the future is that when you have successfully made first contact with an alien race, then at that point you then have the option to bring one of them on board as a crew member. So as you explore the galaxy, and as you meet more races, and as you get friendly with more of them, that opens up the scope for backfilling your crew with alien crew members if you've lost people. So yeah, inevitably you're going to lose crew members during the course of the mission. So being able to backfill them with aliens would actually be really useful. Yeah, because we've got backers that are obviously designing their own alien races, and quite understandably, the backers want to be able to play as the races they're designing. So we're just going to have it as an unlock, where once you have successfully met them and you've successfully made first contact, at that point they are then unlocked, and when you start a new mission or when you go back home to Earth and backfill your crew, you can then select them as part of the race options when making those crew members. But I much prefer the idea of having them unlockable via successful first contact rather than just having them available from the beginning. Yeah, we'll definitely use the crew quarters for that. So at the moment, you can obviously go to character customization and change all these bits and pieces here. We'll have it so that quick actions are available everywhere, like taking your jacket on and off, taking a hat on and off, that sort of thing. Things that you could quite naturally do outside of your crew quarters. But when it comes to like a full outfit change or a hair change or anything like that, we'll have it so that the mirror in your crew quarters is the interface for doing that. Yeah, the backer races system is basically the procedural system with all the knobs and buttons handed over to the backers. So there'll be an in-game tool that's usable for that. In fact, not just the backers either, but also generally for local games. So the Star System Creator tool and the Alien Race Creator tool predominantly will be built for the backers, but for non-backers, we'll have them available anyway. And you'll be able to make your own star systems and your own local races that are local to your game only. The difference with the backer version is the things that they create are actually in the game for everybody. So when they design their race and they design their star system, it's added to the actual game, whereas the local version is just for your local save only. But yeah, it will be a toy people can play with. Right, so we want that to target that. Almost. What are we actually setting? So if we go navigate to there. Okay, so it is targeting the right system. Okay, that's okay. No, that's good. It's just got the wrong name. So the target type is correct. Radius and everything's correct. It's just saying unknown. Oh, of course. No, it would do. Okay, yeah, because we haven't actually scanned it yet, we don't know what the object is. But that said, we're giving it the unknown object name because we are specifically choosing level 0 as our name here. So level 0 is always unknown, and then you've got like terrestrial planet, and then that would be like an atmospheric terrestrial planet, and that would be specifically an Earthlike if there's like life and stuff on there. So we want the level 1 name. We will actually do a full scan check on this, because again, the data holds all of the different options. And these are obviously unlocked depending on what your scan level is. So we don't want to go ahead and say, right, we'll call it an Earth-like world if you don't know that it's an Earth-like world yet. So we don't want to jump the gun on that. So what we would have to do is get sensors, get exploration data. And here's a macro I provided earlier. So if we give it the galaxy coordinates of a star system, it will spit out the exploration data for that specific star system. And then with that known, what we can do is we can go through and loop the planets within that star system, check their their exploration level and compare that to the local coordinates of the world that we're looking at to glean the exploration level, and then we can use that to determine which text field we're pulling from the list. So there are several layers of checks that we need to jump through before we know what's the correct name to choose. So for now, I'll just use the basic name of what type of planet it is, i.e. terrestrial or gas giant. And we'll save the jumping through the hoops for later when we actually build this more fully. So the same with this one, we want to make sure we do level 1, not level 0. You are correct, Madman, yes. So the way the 2D and 3D terrain is going to work is that we'll be using the same shader for both. So if this is the work in progress planetary shader, and what we'll do is we'll unfold this into a 2D plane. Obviously this is using a different version of it, which is why it looks different. Yeah, so we'll unwrap this onto a 2D plane, and this is a seamless sphere, so there are no seams or borders. It's not using triplanar projection or anything like that. It's properly calculated to a sphere. So we have an absolutely borderless, seamless, consistently scaled height map across the whole sphere. So we can flatten that into a 2D plane whilst retaining like border overlaps and things, so that it can repeat across the 2D surface. But when the character reaches, say that's the border down there, when the character is standing at the border, they can still see the planet beyond. But what it would do is it would teleport the player from essentially there to there, but on the opposite edge of the 2D plane. So you're looping around the planet to the other side by just being teleported across the border. The only area where that's really going to be noticeable is at the pole, because at the polar cap itself, obviously that loops around to a point. So we're probably going to have a mountain range or something on the pole that removes the character from the exact point where it loops, because that would probably cause all kinds of issues. That's basically the far corner of the square that we'd be generating on the ground. But the reason we're doing that is so that what you see from space is completely consistent with what you actually explore on foot. And also, because what we want to do is, we don't want to have pre-configured landing zones. We want you to be able to fly around the planet arbitrarily like this. So if you say, right, I want to go and land over there somewhere, all you need to do is kind of nosedive the shuttle at that position on the planet, and whatever you are above, say it was this lake here, if you're nosediving towards the exact middle of that lake, when the surface environment loads, you'd expect to see the same lake in the same place. So by using the 3D version and unwrapping it for 2D, we ensure consistency between space and ground, to make sure there's a one-to-one relationship between the two. So what you see from space should always match what you see on the ground. Obviously the ground version will be a lot more detailed. But yeah. I've forgotten the name of the projection now. Is that it? Mercurial projection? Is that it? Hang on, let me... Mercator projection. Yeah, so it's basically, it takes the sphere and unwraps it. That's the one. Yeah. So we'll just do that. So the sphere, so it does mean that like the northern and southern hemisphere, as you go into the polar region, will be stretched weirdly on the surface, absolutely. But it's just, you need trade-offs somewhere. I mean, what we could do is map it to a perfect cube, but yeah, we're probably going to have to use Mercator projection to map it to the surface, unless there's a better way of doing it, in which case we'll do that instead.
Initiating long-range survey.
Potentially, I mean, it's a long old problem, isn't it? How do you map a sphere onto a 2D surface? There has to be some way of doing that projection. But yeah, the only solution to it really is to have a spherical surface that everything has directional gravity on. Because the reason that we're using a 2D plane is that obviously the gravity direction is down. If we had a sphere, then gravity direction has to point towards the middle, which changes the whole physics engine in the game. Yeah, games like No Man's Sky are built with directional gravity in mind. So on that game and Elite and Star Citizen, they don't have gravity always going down like Unreal Engine does. So we would have to have our own directional gravity system to make a spherical world that you can walk around. It's not an insurmountable problem, but it makes a lot of things more difficult. Things like terrain shaders. Like terrain shaders generally take the height of a height map as the thing that drives the kind of the colouring and the texture and the materials and things on the terrain. If you make that into a sphere, then all of a sudden it's not the height map necessarily you're driving, it's now distance from the centre of the planet. So it changes a lot of the calculations. So our approach to doing this is really designed around how can we maximise graphical fidelity by using all of Unreal Engine's built-in PCG tools. So if we have our planet as a flat plane that teleports at the edges to simulate a spherical world, then it makes it much easier to draw forests, lakes, rivers, spawn content, have animals walking around, have full physics interactions, being able to have boulders rolling down hills and all the other stuff. To do all of those things and to have these dense, lush environments, having it as a sphere makes all of that 10 times more complicated. Whereas just having a flat terrain that may as well be a sphere when you walk to the edges. Like when you're on the surface, you can't tell that it's a sphere. Like if you look out your window, you can't tell that we're on a ball. So it's, you can only really tell that we're on a sphere if you get high enough above the terrain, and you won't ever be that high when you're on the surface. So really, it's not something you're going to notice. Like things like the skybox will rotate that as you move around the planet. So things in space, when you look up, will be in the right place and in the right position. And as you're moving across this 2D plane, we're rotating the skybox as you're walking, as if you were walking around a sphere. So everything you look at, the position of the sun, the clouds, the lighting, all of that will behave as if you were on a sphere, but it's just in reality you're not. But it does mean that we have all of Unreal's tools available to us to play with if we do it that way. Yeah, it's the issue is it's more physics and the need to move things. So, like the reason, let's take Elite Dangerous for example. Elite Dangerous's planets all move, and because of that, they can't have like dense forests, because you would have to have a dense forest with every single object moving as part of the physics engine. And there is a very low upper limit on the amount of stuff you can move all at once within a game engine. And it is for that reason that our ship interiors are static and we move space around the ship. But because we're moving space around the ship, it means we're having to move celestial objects. So because those celestial objects are moving, it means we cannot heavily populate those objects with ground clutter whilst having them as a moving object. Which means we can't do real-time landings, because the only way to have a real-time landing would be to sacrifice all of the ground detail and basically just have a terrain covered in rocks. Because anything like trees and foliage and even creatures would have to be very, very sparse, because they all have to move with the planet. But by having a static environment that is a separate environment to what you see out the window from space, it means that we have no limit on how dense we can populate that surface. So we can have literally like jungles that you have to hack your way through, that they're so dense with foliage, because that surface is static, it's not moving. And because it's not moving, we don't have to worry about having to move loads of objects around. So the trade-off of having a static planet that you have to teleport down to is that you get really, really lush environments that are absolutely packed with content, as opposed to a sparse environment which is moving. So yeah, it's which is the lesser of two evils. I don't know, Mabon. To be honest, I haven't looked into it in that depth. But it's the issue is gravity direction and physics. Yeah, it's Unreal's default character class only supports down as a gravity direction, and the engine itself only supports down as a gravity direction. I mean, you can turn gravity off, or you can change the value of gravity, but it's only ever just going down in engine physics terms. To have gravity go in a different direction, then you're having to mess with the physics engine itself. And it's, as I say, it overcomplicates absolutely everything. Now, that said, we do want characters that can walk upside down underneath the ship, for example. And we need characters that can orient any way possible, because when we have things like asteroids, we want to be able to walk around an asteroid, including upside down. And the only way I know how to do that right now is to make the character essentially a flying pawn, so it's no longer inheriting from the normal character class. It's essentially treated as a flying object. Which means it can then orient any direction you want it to, because it's flying. And then you use arbitrary forces to have that go in a certain direction to simulate gravity. But at that point, you're basically faking gravity, as opposed to having it actually calculated within the physics engine. And then every object, like crates and props and things, if you are throwing them around in that environment, then they're reacting to physics fields which are having impulses applied to them in whatever gravity direction you've chosen. It's not real gravity, it's not part of the proper physics simulation, but it looks like it as you're playing, and I suppose it's the next best thing. But that's fine in a local environment, and it might be fine for something like an asteroid. But if you're talking planetary scale, then you would need these physics boxes applying an impulse to something across the entire planetary terrain. And again, it's one of those things where the amount of effort that you would have to go through to have a spherical world working that way, it is greatly outweighed by the simplicity of just making it a 2D terrain, which is planet-sized. And we're not talking a small 2D terrain here. It is a planet-sized 2D terrain. And you wouldn't notice the difference. Whether it was 2D or 3D, you literally cannot see the difference at ground level. So it's a lot of effort for no real reward, other than knowing the fact that it's a sphere. And like I said, by having a flat terrain which is static, we can have an unlimited number of forests and trees and rocks and squirrels and whatever we want on the surface. Our goal is lush, densely populated environments that are like as immersive as they possibly could be. Illusion, no, you can't change the direction of down. No idea, Sawbones. I haven't actually looked into it. So I just want. So everything seems to have gone through as we needed it to. So that's correct. That's correct. But that didn't update immediately. So we just need to make sure that this is refreshed when we press this button. But that side, that is all working exactly as we need it to, which is good. Yeah, for sure. If there's a better way of doing it than using a Mercator projection, then I'm all ears, for sure. Yeah, the good thing is, Danger Mouse, is we have meta sounds in Unreal Engine, and something meta sounds can do is it spawns audio procedurally around you as you're walking around. So, and that is specifically designed for things like forests. So you can hear things like a bird or like an insect buzzing past you. And those audio sources are constantly pinging in and out of existence as you walk around. So you don't have to pre-place or pre-spawn these audio sources. They're always just there, just spawning as you walk around. So it doesn't matter how far you walk in a given direction, it will always be spawning these audio sources near where you are, creating the illusion of dense life around you, which is really cool. I think once we get to doing planetary surfaces properly, and once I can focus 100% of my attention to it, I'm going to lose myself doing that for sure. It's something I'm very excited about. Charlemore, yes. The NPCs, I guess they're going to be similar to RimWorld, but probably more like The Sims. But Sims without you ever having to get involved in their lives. So they won't have schedules as such. They'll have, well, I suppose they will in a sense, because they'll have 3 states of being, basically. Either they're on shift, off shift, or in bed. And they'll take themselves to those locations automatically. If they're off shift, they'll go and partake in all the entertainment activities on the ship. They'll either just go and sit in the bar, or they'll just walk around the ship. They'll just occupy themselves in any which way they see fit. If they're on shift, then they'll be obeying the task manager system. So tasks will be raised that are relevant for their particular department, and they'll be doing their day job, essentially, analysing stuff and flying the ship and doing whatever else they need to do. If they need the bathroom, they will stop work and go to the bathroom. If they need food, they'll stop work and go and eat something. So we're letting the NPCs manage their own needs. So you won't ever need to tell them to go to the bathroom like you would in The Sims. They'll just go to the bathroom when they need to. And we're kind of build some logic into that. Like, if the ship's at red alert, then they won't just get up and go to the toilet because you're at red alert right now. So they'll be intelligent about it. But I want the ability to follow an NPC throughout their entire day and have them have their day no differently than a human would. So you can literally watch their routine, stand outside the bathroom while they go for a loo, and then when they're done on the toilet, you can go and watch them where they go next, and literally watch them live their lives aboard the ship. So we'll have 200 crew members all living an actual life aboard the ship, which will be really cool to see. Yeah, Dwarf Fortress is a definite inspiration for this. Claire in particular is a massive RimWorld fan. She sort of gets into RimWorld every few months, and you kind of lose her for a month while she just loses herself in RimWorld. But yeah, I've tried to get her into Dwarf Fortress, but she struggles with the kind of the low fidelity of that game. But yeah, I love Dwarf Fortress. I think it's amazing, the world building that it does behind the scenes, and just how deep everything is. And that's exactly what I want for this game. I want our NPCs to be like Dwarf Fortress, and I want the alien races and the background lore and all the details for those alien races to be as deep as Dwarf Fortress. So the systems that procedurally generate those races definitely need to go through like thousands of years of history to make sure that when you meet that alien race and you start researching them and looking at their history and grabbing their artifacts and doing science on them, the stuff that you find out for that alien race, there needs to be like an endless well of information that you can draw from, so that you can spend literally weeks researching a single alien race and have all that detail there available to kind of pull out of the science that you do. That's the kind of stuff I get excited about. Yeah, when it comes to LLMs and having the NPCs be AI powered, I mean, yes, at some point we definitely do want to do that. But as I've said many times, our line in the sand for the point in which we transition to making the NPCs LLM powered, it needs to be a small local model that runs within the game engine and is trained on our own data. So that if you ask it, or if you go up to an NPC and say, did you see the game last night? They'll be like, what? And they haven't got a clue what you're talking about. And if you ask them some political question about Earth, they won't have a clue what you're talking about. So we need to feed the NPCs the game data and the game data only, so that they can only really converse about things relevant to the game and relevant to what's happening. Like, what do you think of that object out the window? They should be able to tell you what's out the window, because the game is feeding them with that information in their context. You can get 1 gig models, and they're surprisingly good for their size. So you're only talking about around about 1 gig of VRAM to host a local model within the game. And that should be sufficient for just a conversational AI, because we're not asking them to solve science or anything. They just need to be able to hold a believable conversation. But the issue with the local model is that you have to run a server. So you have to have like a Python server or something running that's actually like running on localhost, so that the game can use Python to speak to the model, and then the model replies back. I think we were using VA REST last time we tried it, but you need to run a local server running the model in order for it to work. And for me, that's no good. I want something that doesn't require the user to install something separately. It has to be something that runs within the engine, and the AI model that we're querying is running only within the engine. So it doesn't require an external connection. It doesn't require something being installed on your PC. It literally runs as part of the game. If we can tick those boxes, then I'm open to experimenting with it, definitely. No worries, Shalimore. I'm excited by it too. Yeah, sure, Mappin, go ahead. Yeah, the question over LLMs is always a difficult one, because there are a lot of people who have very bad feelings about AI across the board as a blanket statement. And there are different types of AI, and there's a very wide spectrum of good to bad. And we're not talking using generative AI to make game assets or anything like that. No, definitely not. What we're talking about is having a locally hosted model within the game engine driving NPC dialogue, which is a very different beast to generative AI creating 3D models like on the fly for the game. Although at some point in the future, I'm not necessarily going to rule that out, because again, if it's running in the game engine, then this could be a solution to an infinite number of alien races within the game. Because if you send down a probe to an alien world, and that probe is able to come back with something truly globally unique, like an ornament or something, or some alien statue that is unique to that world, then without literally hundreds and hundreds of 3D modelers creating content 24/7, you're never going to be able to generate enough content to populate an entire galaxy's worth of alien races. So it might be that a tool like that in the future is the only way we can get the depth that we want to get from these procedural alien races. But I'm all about using these things properly as a tool, and understanding it fully. Exactly, Fredishay, and I think that's the thing. If it involves anything outside of the game engine, I'm not interested. So it has to be something that only runs as part of the game, and as soon as you close the game, it's gone. It's not running anymore. So the idea would be you'd open the game would suddenly suck up 1 gig of VRAM to host its local model, and then and then that's it. It's basically just querying VRAM whilst the game is running, and as soon as you close the game, VRAM is dumped, the model's gone. And that's it. That's our line in the sand. Unless we can achieve that, we're not doing it. And I think that's probably what a lot of people would expect. And that's the only thing people would accept as well. But it's still early days when it comes to AI. You know, as much as AI is advancing in leaps and bounds, pretty much week by week at this point, it is still very early, and the court of public opinion is still, varied, to say the least. Yeah, it will end up with some sentient AGI model that turns into Q within the game or something. That doesn't surprise me, Delta. I probably won't stream Artemis 2 later. No, I don't even know what time the Splashdown's scheduled for, to be honest. Hang on, I do actually have it live. Oh, it's not going to be a while yet. I mean, they're still that far away, so I don't imagine that's going to be more than, probably at least a couple of hours before they get close enough to land. How cool is that view, though? That is a very cool view. Okay. Yeah, I'll probably end the stream at midnight and then go watch it. It's very true, yeah. I'm a big believer in the overview effect, and like I said a few years ago, actually, working on this game, and looking out the window, and I spend most of my time working in space, looking at Earth, within the game engine, and yeah, the overview effect is real. I mean, it really does give you a different perspective on the world when you spend all of your time looking at the world from a distance. It's you don't see borders anymore, and I think everyone should experience that. Completely forgot what I was doing. Oh yeah, we needed this to update automatically, didn't we? Let's go and find player controller. Yeah, and from what I've heard from interviews and things with astronauts, is what you can see with your own eyes is obviously a lot more visually impressive than what you see from a 2D screen on the camera. Just the difference in colours, and looking at stars outside of Earth's atmosphere. One astronaut was saying that the difference in colours between all the stars when looking out the window is so much more pronounced than when you see it from Earth, and I love to see that. I need to have a word with Elon or something and see if I can get up on a rocket just to do it as research for the game. It's research, honestly. Maybe I should start a GoFundMe. Put down on a rocket. I think what I'll do is I'm going to add a new channel to Holo display, just basically just forcing it to refresh, because that should kind of generically just give us something that we can fire whenever we just want the Holo display to update. So make our dummy payload. So whenever we set our replicated command target, we'll then just forcibly refresh the Holo display, which will then hopefully pick up on that target. Thanks, Madman. I shall take a look later. Yeah, I think once SpaceX's Starship is rapidly reusable, obviously that's the goal, and they are going great guns towards that. But once that's actually a thing, the amount of mass that we can put in orbit is going to be insane. Like, that thing can loft 100 tons into orbit every single flight. So building stuff on the moon and building stuff in low Earth orbit is going to increase exponentially. Yeah, I think, and it's not just SpaceX either. Obviously, you've got New Glenn from Blue Origin, and that's going to do a similar job. And I think Jeff Bezos said a long time ago that their goal with Blue Origin is to become like the DHL of space. So they want to move industry to the moon, and basically create that kind of frontier railroad to space. And I think that's that's exactly what we need. We do need to move our heavy polluting industry to the moon, where it's no longer harming our delicate biosphere. That's going to create a lot of jobs in space, which will be an exciting time. Right, so whenever this is triggered, we need to make sure we update doing on here. So yeah, we just grab that. That should do everything. Let me see whether or not we actually need, well, I suppose for future-proof reasons, I'll leave it on full refresh. The difference between doing that or not doing that is full refresh literally deletes and redraws the entire display, whereas not doing that only just updates a couple of things. But if we're using this as our generic trigger for refreshing the whole thing, we're better off just refreshing the whole thing. For me, it's the lesser of two evils. I mean, if you need to do heavy industry, you're better off doing it on the moon, where there is no biosphere, than you are on Earth, where pollution can do a lot of damage. At least on the moon, it's not harming anything, and it's it's not littering space itself. It's limited to the moon, but the moon is essentially just a big dead rock.
Initiating long-range solo.
But yeah, we do need to clear up low Earth orbit. I've seen some fascinating proposals using like big nets and things to start dragging things down. But again, I think when the cost of access to space goes down, where things like Starship will really help. If putting giant nets up there becomes really, really cheap, then that's a great way of clearing the orbit. Hurrah! There we go. Now it's updating. Okay, so we're now successfully finding Earthlike worlds. We're successfully finding tech signatures. We are successfully raising command orders. And those command orders are successfully able to just target the thing that was found during the sensor sweep. So tick, tick, and tick. That's good. We've got an hour to go. And I think... what should we do? I was tempted to look at moons. But there's so much involved with that. Let's have a look at it. I'm not going to guarantee that we'll be able to add moons, but let's just have a look and see what complexity it kind of does offer to us. So, first and foremost, when we go through this behemoth of a blueprint and generate a star system, generate all our star classes first, and that's basically our central object at this point. When we do the full system with multiple stars and berry centers and literally 2 stars, both with their own planets and moons, then the berry center needs to be the very first root object of a star system. And we'll probably keep that even with a single star system. We'll still have that berry center there as the root of the system. So we need a data structure which can basically take a root object and then have children around that object, but then have those objects also be child objects of other objects. So what I'm doing at the moment is we're nesting a struct within a struct. So when it comes to actually adding the object, we've got this array of structs, which is basically everything within a star system. I need to rename this celestial objects really, because it makes more sense. But we just add each planet to the struct array, and then we read that later to spawn all the planets. So each of these large system objects needs to have its own array of child objects. So the issue with this is you cannot have a struct be a child of itself. So this say we renamed this to struct celestial object, then you couldn't have an array of celestial objects within this struct because it's of the same type. So we would have to have a different struct for, say, moons, which is fine as a workaround for this. So we could just have a copy of this struct and call it moons instead, and then just make an array of moons for each planet. But that doesn't really solve the problem across a system-wide scale, because you need to have an arbitrary arrangement of moons, planets, stars, and barycenters. So really, you need like a monolithic struct of everything within a star system, with unique identifiers specifying what child and parent objects relationships are. So this object ID and parent ID, that's where those would come into play. And then you'd have, again, literally everything in one long struct, which is everything that exists within that star system, so that we're not having to nest structs within structs, and causing ourselves problems with you now can't add this object as a child because that object is already a child of this type, and that type can't be a child of itself, and blah 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 blah, thus making life really awkward. But as a workaround for now, we can make a separate moon struct and have this do the same job that we do here. So where we define a system mass in kilograms, that's basically the mass pool for this entire star system. So that's the mass of our protoplanetary disk, which is in kilograms, which is a very large number, as you can probably imagine. So when that runs out, we stop generating planets, basically. So we need another one of these for moons. So we have a moon mass that we can work with. Although, I think for simplicity's sake, we could just randomly sprinkle moons rather than doing it like this. Because as far as planets are concerned, it's easy because you have this mass budget to begin with. You've got a protoplanetary disk that you're collapsing into planets. For moons, either they were formed at the same time as the planets and they just happen to have a coexisting orbit, or they're things that have been captured or things that have been like smashed into and trunks ripped off, and then they end up as moons. There's lots of different ways in which moons can end up where they are. So if we were to use captured objects as our basic definition for moons, then we can just use a random number based on object mass. So that the larger the object, the more moons it has. Like Jupiter's got like 90 odd, I think I read last time. And then we define a budget from there. So there are several ways we could do this, but I think when we construct this, we're going to have to make a new array on here for moons. So let's go and do that, I guess. I don't think I'm storing that anywhere, so I'm going to have to go and find it. Right, so there's our planets. So if I duplicate that and just call it moon. Yeah, moons, that'll do. This isn't going to last. This is only going to be until such a time as we do the berry center solution properly. But then what we need on here is we need to add an array for moons. Thanks, Iris. Yeah, I know this is like a rapid fire challenge, but let's see. Yeah, don't get too excited, Anasi. This is just a placeholder for moons as opposed to the actual final solution for moons. Now it just so happens that we have a lot of the code we need already for this, because if I can find it, there it is. We're already tracking things like hill sphere. Where is it? Somewhere. Yeah, our hill radius for the planet. So we already know how far away the farthest moon can be. And we also have our planetary Roche limit. So if a moon is within the Roche limit, then it becomes a ring because it would get torn apart. If it's outside of the hill radius, then it would float off into space because the planet can no longer hold on to it. So we have an outer zone in which we can spawn moons and have them actually successfully work in an orbit. So we have that data. So that's like the first puzzle piece already sorted. But then what we would have to do is work out where in the star system the moon would be, bearing in mind that right now we are like locking the planets into place. So we're generating an orbit, we're picking where on that orbital ring the planet is, and then that's where we spawn it and it stays there. So we need to know essentially the local coordinates of the moon. So let's just grab a list of things that we need a minute. Okay, so this is where the planet is. That's our zone where moons can validly be placed. So then we need to then work on moon scale, and I guess we'll just go from Earth's moon down for now. Yeah, so we grab those. What's the best time to do this? I mean, really, I suppose here. So, yeah, because we're generating... That's all like the planetary core stuff. And then we have a different set of calculations if it's a gas giant or terrestrial planet. But they all basically end up with this construct object. So if we add another one here, so let's just pop them in and collapse them to a graph. Let's call that generate moons. Okay, so before we generate the planet object, we'll generate some moons first. So we could use base planet type as our driver for this, but I think it's probably easier if we use our base mass. We're using the same mass value? Yeah, final planet mass. So we'll grab that. Because we can use the mass of the planet to determine the number of moons that we spawn. And then we need an array for basically a copy of that. Okay, so we're just going to create, for now, one moon. And then we'll see, well, we do one moon per planet. So every planet has one moon. And then we'll see what that actually looks like. So we already know that. We know that it's going to be a moon. Did I not add moon on here? Why would I not have added moon? If we treat them as dwarf planets for now, I guess technically a moon is a dwarf planet. If it wasn't around a planet, we'd call it a dwarf planet. And then some moons will be basically asteroids, but we can class them as moons. Okay, and then the local coords are what we need to generate. So where is our orbital stuff? Right then. No, we don't want that. We want that. Yeah, there we go. That's what I was looking for. think something else we're going to have to do is, see, we have a random stream that we use for the planet stuff. I think it would be worth making a second one for moons, because otherwise, every time we hit this random stream, we will be changing the planet data itself, which we don't want to do. So let's kind of make this slightly more robust. So we'll use a moons one, and we'll make sure that we specify that. Where are we doing that? There. Did I mention this needs cleaning up? Because it really badly needs cleaning up. Yeah, I'll use the same base seed for both of them. Obviously that's going to get hit a lot more often than that is, but it doesn't matter that they have the same base seed. We just want to avoid using this one for the moons because it will change our star systems in ways that we don't want. Right, so we'll grab that. Now, where was this? Okay. So we will set these values directly. So that's basically whereabouts in the orbit the moon is, completely random in a circle. This is where we decide whereabouts the moon is. And we also need to know the inclination of the planets. Yeah, the planet inclination. So I guess, yeah, so the system inclination becomes the planet inclination. Because we want the moons to be on the equator, basically. Yeah. We'll leave that at 0 for now. We can randomize that. Okay, so that needs to go in there. Make this just a random int for now. Right, and then we need to make all of these. so for a bunch of these, we'll just take these values from the planet. In fact, let's take the values from our moon. Oh, autosave. Why do you always get in the way? Okay, so the radius is the important one. I won't worry about any of this for now. Yeah, so none of these values are going to affect the way we draw the moon for the minute. Obviously, there'll be nothing on the scan data, but it's the radius that drives the biggest visual change. There is no atmosphere, so we don't need that. Don't need any of that. We will need some of that. We don't need that. Just need to work out what class I'm using for where are we? Draw planets. Planet procedural. Did that one, didn't we? So in order to draw the objects in the world, we need to make sure we set these orbital distances from here. Average distance, eccentricity. Yeah, well, that usually would plug into there, but we'll just leave that one. Don't care about any of those for now. If we have any child objects, we'll need those. Okay, so it's these values here that we need to set. Just need to work out what unit of measurement they are in. suppose the easiest way of checking that is to look at these ones. So, what are we driving it with? Okay, yeah, so. Yeah, so if we do a random float in range, the minimum is that and the maximum of that. Convert that to centimeters. And they can be the same. So that's a perfectly circular orbit, basically. Obviously it won't be when we do it properly, but just for testing purposes. So that should give us... actually, it's going to hit this twice. So actually, it'll probably be quite eccentric because it's going to do a different value each time, but we'll see what it looks like. Yeah, so this should give us a moon that is being positioned that far from the planet. I guess what it's going to do is it's going to draw these moons inside of the star because it assumes the root location to be 0, basically. Yeah, because it's doing this from a 0 point. So I think if we get our local coordinates for the planet, and we simply add those two together, that should give us the offset we're looking for the moons. Hopefully. Okay, now when it comes to constructing the planet object, we've already given it a... Oh, that moons needs to be an array. Let's just fix that. Ooh, actually. We might be okay. We might not need to change... Refresh that. Might not need to add the vectors together, because of course we're drawing this from a separate array. Yeah, we've got 45 minutes to go. We can do this. My goal is to have a moon around something, although every something will have one moon at this precise moment. But once we get that as a starting point, then we can take it from there. Right. So one moon in an array is being added to every planet. Okay. Let's see what we actually end up with. Oh, just refresh all these a minute. Yeah, so nothing on the central star. What are you? Trans-Neptunians. Don't need moons on those, although we will add... Actually, no, we will. We will add those. Pluto has moons. don't know where that one's come from. Is that this one over here? Yeah. Yeah, okay, yeah. That can have moons too. Rogue planet. Yep, you may as well have moons. Very unlikely, but why not? And Sajay doesn't need moons. Yep, Hales will be coming reasonably soon. Because I want to do the comms next after I've done what we're doing with here. We definitely want to add comms. Ugh, everywhere there's a reference to this now, it's going to be wrong because I changed it to an array. Let's work out which one of these is failing. Right, so what we need to do now is go in our reference viewer and look at every single thing which uses that struct and make sure all of them are compiled and saved. So that one's going to be broken. Yeah, so the reason all of these are coming up with this error is because that struct is used within the sensors data. So by compiling something else elsewhere, that might very well fix it, but let's just go through and do all of them. Actually, if we close absolutely everything, then we can open all the ones that reference that struct and then close them as we go. So we're only left with the ones that aren't compiling. This doesn't help with our challenge, does it? all those things are referencing this struct. Can we open all of them? That would be handy if we can. Okay, so I'll leave that one open for a minute. Need to work out which one of these is erroring. So I've had it before where, because one thing didn't compile, anything referencing that thing also won't compile. Same problem there. You're all right. I think I might actually need to redo the breakage of that, which would be annoying because I'd have to do that in every blueprint where it was broke. I'll just see if it's the one pin that's doing it, like this here. So if we were to do that, compile, then do that. So selected location knowledge and selected system object. So if we get rid of that and then we do that. Yeah, okay. I'm kind of glad that that's actually still bringing up a warning, because otherwise I'd have to do that everywhere. Which one's this? Oh, that was that thing I made. It's not even used anymore. Did that do it? There we go. That fixed it. Problems resolved. It's really annoying when you spend like half your time troubleshooting stupid stuff rather than getting the thing done that you wanted to do. That cost us 15 minutes, that did. Okay, no moons yet, although let's just check on system over. won't be doing, of course, is drawing them. So we need to get our live, no, not that one. That one. Sector location. Yeah, so we go through each of our satellite objects in a system, and then for each one of those we spawn whatever it is. But in addition to this, we now need to also spawn its moons. So yeah, so I guess if we drag that over there a minute. So first we'll do that, and then we'll do that. Yeah, I guess we're doing pretty much exactly the same thing as we're doing here. What I'll do is I'll grab all of that, pop it down there, and we'll make a custom event for it. We'll call that render moon. Okay, so we want our class. And our location. Well, let's our local coords to be specific. So for each one of those, we will render moon. And we want our class and local coordinates. Need to make that moon. Yeah, then down here we want to put moon in there instead. Oh, of course, which we can't do because that's a different type of struct. But what we can do, oops, is just cheat. Because although they're different structs, they do have all the same fields, so we can just convert one into t'other. Save having to make new interfaces or anything for it. Again, this is a test, so we don't need to be precise with it. Okay, and it will create that as a system object, so it should exist within the star system. There's probably going to be a few places that I'll need to reference the fact that there are moons. Thank you, Delta. Okay, so nothing showing on the sensors there, but Sol is a custom system, so that might explain that. Still the same number of objects there. So for each object, we render the planet, then we render the moon, we're adding it to our system objects array, so they're in there, and they're being treated like dwarf planets, so it should render them as dwarf objects. Let's just do some debug on here. Just to make sure that it is actually adding some moons rather than ignoring us. Right now, the moon is a child of the system because we're adding it as a system object, but we're getting it from the planet. So it should appear in the list of system objects alongside the planets. So they won't be nested as a separate object. It will just appear as another planet, basically. So it would be like planet, moon, planet, moon, planet, moon. That's what I would expect to see. See, I'm not seeing anything there of the text. Okay. So it might be actually the case that they are there out the window, although it wasn't saying that it was spawning them. Let's just see how far we get with any of this. Basically, as soon as the game starts, it should immediately say that it's trying to add moons. Okay, so it's trying to add a moon on every planet, but not. So if we grab. Where is it? Grab that. I need to make sure we're actually adding moons on our custom systems. Too many collapsed graphs. Let's just get rid of all these a minute. Oops. So custom system. So if it's a custom system like salt, right? Yeah. Okay. So that's what's missing there. Yeah. Right, so we should get some now on the song system because it's a custom system. That's why that blueprint's such a mess. It's because we added a bunch of custom stuff recently. Okay, so it's adding 1 moon per planet. Okay, there's nothing on the sensors, but that makes sense because the sensors won't be looking at that array, and neither will that. But we should have a moon somewhere around here. Of course, it could be anywhere. If the offset worked, of course, which it's not guaranteed to have. But the moon should have like a distance proxy, so we should see it moving if it's indeed here. Not seeing anything moving. Okay. Right, so when it comes to the coordinates then, I think what we'll do is we'll remove that offset from there. And then when we actually generate the moon, we will grab our large system object. Where are we? Yeah, there. Okay, so that's where the planet is, and again, the coordinates of the moon will have been based around 0, 0, 0. So if we simply add those to there, then that should put the moon within range of the planet. In fact, just to prove that to ourselves, because it's always good to have a debug. If we do distance from the planet to the moon, yeah, just plug that into there. And do centimeters to kilometers. Right, that should be the kilometer distance that the moon is from the planet. So that shouldn't be too big of a value. Ooh, those are some tiny numbers. Okay. Those are not the numbers I was expecting. Oh, I wonder whether that might have actually been... No, that can't be kilometers, surely. No, that's definitely not. Yeah, that should definitely be outputting in centimeters. I need to update these and make sure that they definitely have the right unit associated with them, because getting the whole centimeters to kilometers thing mixed up causes a lot of problems. Yeah, so we're inputting that definitely as centimeters. So hang on, let's just make sure. Oh, look, I'm being an idiot. Oh, it's because the macro isn't available on this type of object, blueprint component. That'll be why. So we'll just do that manually. 0.0001 kilometers to centimeters. Right, so it doesn't help that we had the wrong unit of measurement in there. And we'll just make sure that we also do this for the procedural systems as well, rather than the custom ones. Okay, let's try it again. Okay, we're still getting tiny numbers. Let's just do a quick moon check. Not seeing anything that looks like moon. Let's just see what that distance actually is in centimeters, because something's not adding up there somewhere. It might very well have done a NASI, yeah. If the distances are that small, yeah, we're talking like single centimeters in some cases. So let's go fly inside the planet and have a look. You there? Get out of my chair. Not seeing a moon. Oh, hang on, what's that? Is that a moon or is that Earth? Could very well be a moon. Hang on, let's go quicker. Yeah, that was a moon. Okay. The moon is inside the planet. That would explain that. Right, what are we getting wrong here? Oh, math. That's what we're getting wrong. Because that's the centimeters to kilometers calculation, not the other way around. Length converter. Right, so we want 1 kilometer in centimeters. That's the number we want. And again, let's make sure we do this on custom systems as well. Right, this time it should not be inside the planet. There we go. Nice healthy centimeter numbers. So somewhere around here there should be a moon that we can actually see. Oh, there it is. Let's go check that out. To be honest, that's distance-wise, that's not far off the actual distance that the moon would be. This is actually the right size for the moon, because I put in the moon's radius as our test, so this is correctly moon-sized. And it seems to have a stupid little atmosphere stuck in it for some reason. Oh, actually no, that's Earth. Oh, yeah, I forgot that. Yeah, I need to fix our atmospheric render because the atmosphere is set to ignore depth checks, so the atmosphere appears behind things. But yes, Earthrise. Hang on a minute, what were those other things? Do we have more than one moon? We do. Why do we have 3 moons? We seem to have gone none at all to too many. Hmm. See, Mars seems to have too many moons as well. Okay. Oh, I think I might know what's happening. We're not clearing the array. So it means... Yeah. So Earth has got 3 moons because it's the 3rd planet from the Sun. But then... it would add 1 for the Sun. So that's not enough moons. There must have been some more that we didn't see. But yeah, so every iteration of the loop, we need to make sure we clear the moons array. Otherwise, we're adding an unusual number of moons. Actually, no. No, we don't want to do that, do we? Yes, we do. No, we do want to do that because for every planet, we are starting fresh with our moons array. Yeah, so that would be there. Yeah, so each time we create another planet, we have to clear the moons array. Right, okay. So the next thing we need to do then is perhaps put the code back for this. So that we'll do the offset. Yeah, we'll do the offset there rather than doing it when we draw the actual object itself, because that'll make life easier for things like the holo display. So we're not having to do that twice. That one's fine already. Yes, so on the holo display now, we just need to make sure that we also loop through those sub-objects. Yeah, I do that a lot. Right, so when it comes to rendering the array, what we're doing is we're going through each object. Yeah, so all the satellite objects, we're going through and adding all of that, basically. So we quite literally have to go through and do all of that again for the moons. Although, what we could do, yeah, to save some time, if we need to make a new array that has all that in it. Are we using anything else? No. Okay, so Right, hang on, now I've got a plan. So for each one of these, so this is a large system object, yeah. So for each one of those, we're going to add it to a temporary array. So let's just yeah. System objects temp. Okay, and that's going to be an array. So what we want to do is for each of these, we want to add ourselves, and then for each of these, however many moons there would be, just collapse that. Now obviously that's going to be a different struct, so we'll do the same thing we did over here. So that loop is now going to loop off of this instead, and then we will make that by doing make there, break there, and then just duplicating all these fields. And again, the reason we're having to do this is because the nested array of moons is a different type of struct that has exactly the same data in it, but we can't nest the same struct type, so we have to do this. Okay, so for each planet, we add it and all of its moons into the same array of the same types, and then we loop through that and draw the orrery map, which means we're not having to do all that again just for moons. So let's just collapse that a minute. Right, so you can go in there. And you can go there. Right, and then we can tidy this up. So add that, loop through there, add that, and then when you're done doing that, that should be all of that. And then for absolute validation's sake, we will clear that just to make sure that we don't run into any issues with doubled up objects. So clear the temp array, populate the temp array, and then go ahead and draw the map. So we should now have all of our moons on the map. The way that it draws the orbit lines might be a little bit broke, but let's have a look. Let's do the short range one actually. Oh, yeah, there's the moon. Okay. Yeah, so orbit lines are going to be an issue because we can't get close enough to it before it stops drawing. So as we zoom in, it stops drawing the object because of our optimization. I think we're going to have to just update that a little bit so that it doesn't stop drawing so soon. Let's go to a closer one. To make sure we don't draw the moons quite so big with their distance proxy, because it does look a bit silly. Okay, so this is Mercury, and yeah, so the orbit lines stop drawing too soon. Hang on, let's fix that a minute so that we can zoom in a bit more. I just want to see whether or not it's actually drawing them. Yeah, let's just skip that check. That should stop it from drawing, stop it from deleting the ones that are outside of the sensor range. Okay, so it's drawing it, but it's not doing an orbit line. Fair enough. I'll have to try and work out why. But we do have moons, so one moon per planet as a test. And I suppose the only other thing would be to add them to here, so that you can actually target them. See how easy and or difficult that would be. Don't worry. I'll discover that at some point and wonder what it was. You should be able to. Yes, I will double check in 2 secs. So I'll only add them to medium range for now. Right, so where are we drawing them? Okay, so we're going to have to do a similar thing here, where we use this temporary array to add the child objects. Yeah, so we're going to have to just borrow the one we did on here, I suppose. If we give it that as an input, then we don't need that. So just pop that in there. Right, and then we'll use that and that and that. You're very welcome, Festus. Yeah. Well, I'll put this out as a dev build, so that you can have a look at it. But we won't include moons in the demo updates because, well, it's not ready yet. There we go. Moon. So it will render them, and they are on the display. If we zoom in, then can I click on it? I can. Okay. Can we fly to it? I'm not seeing a moon there. Interesting. Okay, so it's not where it thinks it is, but it is there at least. Actually, where is it? Like, where are we compared to it? Okay, so on the short range, it definitely thinks we're there. Oh, I know why. It's because on here we're adding those together, which we didn't need to do. So that can go away and that can go away. Right, yeah, so the sensors and the holo display were correct. It was the actual spawning of the object was wrong. Okay, let's just try that again. So Earth, Moon, not sure whether that's the right moon. Let's fly to it anyway. No, it is the right one. Good. feels better. Yeah, I can see a moon. Okay, good. Yep, okay, that works. And we should... okay, so... It's not sure... Oh, I know why. I know why. Amos, thank you. Very much appreciated. Okay, right, that should fix short range as well. So if we go on here, have a look at the short range, it should be there. So the way I've just built it is that every planet has one moon. Like literally every single planet has one moon. Hurrah! I forgot they were green, so yeah. Ignore the fact they're green. I need to work out why they're green. But the surface map works on them, so that's good. Okay. And then if we do that, and that, and that. Huzzah, moon. Okay. Right, so they'll be available on the holo display. They'll be available on the medium and short range sensors. They won't show up on the long range sensors, but then they wouldn't anyway. On the holo display, I will put this fix back in for the display range, but I'll see if I can refine this a little bit so it's not quite so aggressive. But without that, targets and things appear outside of the holo display, which we don't want. Yeah, and that should basically be that. So what I can do is, just to make this a little bit more meaningful, so for procedural systems and procedural systems only, we can do for loop. then we'll get our random stream for moons, and we'll do random int range. Oops. So that will be, actually we start at 1. So anywhere up to 3 moons, and we're randomizing the position of them anyway. Actually, that should be, to keep it consistent, that should be random float in range from the stream. We want to take our stream, so min, max. Okay, just so that's consistent every time. Yep, so do that, do that. So radius wise, we'll do this, and we'll go from, let's say, 500 kilometers to 3,000, 2,000 kilometers. What was the moon? 1,700, I think I read. 1,700. All right, 2,500. In case there's a really big moon. So you'll have randomly sized moons, random orbital distances, 1 to 3 moons. Although I suppose we'll also do, as a final thing, oops, we'll do random ball with weight from stream. And we'll do a 75% chance of moons. Just so that it means not every single object will have moons. And we'll keep the Sol system as a test for now. So yeah, so 75% of planets will have moons. There'll be between 1 and 3 of them. They'll have random radiuses, and they'll have random positions in orbit. But because they're driven by random streams, they will always be in the same place every time. And we're using the planet's Roche limit and Hill sphere to designate the place where those moons can be. We're not calculating the Hill sphere of each moon, so we're going to get planets right now with moons on top of each other, but it's only a test, so we can live with that. Okay, and that'll be that, I reckon. So let's just make sure that we're on version 11. And we can package this up. So I'll leave this packaging, and I'll give it a test once it's packaged, assuming it packages, of course. And then, yeah, hopefully I can get a dev build out and you can go and fly around some moons, which will be fun. All right, thanks for watching, everyone, and I shall see you on Sunday for more fun games. All right, have a good one, and oh yeah, enjoy the Artemis landing. 39 minutes to go, so yeah, 39 minutes if you want to watch Artemis land. All right, have a good weekend. See you on Sunday. Bye.